Hello my student, today we talk about linear first order equation. This is section 1.5 and from your book. We call the differential equation linear first order equation if we can rewrite our equation with this shape: dy dx plus some function p depend only x y equal some function q depend only x. Okay, now we study how we can solving this equation. Let's r depend x, it will be some function who we defined like e to the power integral your function px dx. This is our multiplicator. Multiply our equation number 1. For this multiplicator we have e to the integral px dx dy dx plus e to the power px dx. We have px y equal e to the power px dx qx. If you're looking for the left part your equation, it will be full differential for product y e to the power px dx. This means left part you can rewrite like this kind of derivative, and it will be e to the integral px dx qx. This means found our solution, take it integral for both sides, and left part if you take it integral it will be exactly y e to the x, and right side will be qx dx. Okay, and final answer here y will be e to the minus integral px dx times integral e to the integral x use this multiplicator. Sorry, it's dx, but sometimes this happened. Use this multiplicator, we can solving, and we found general solution. But remember this formula. I'm not sure you need to remember all this formula. You need to remember method how we solving, and you need to remember this formula, this multiplicator. Okay. Doing some example. Example 1. Let's go, we have x squared plus 1 dy dx plus 3xy equal 6x. This equation looks like linear equation, but we need little bit work with this equation. Okay, write a standard form. This means dy dx, it will be plus 3x over x squared plus 1 y equal 6x over x squared plus 1. This part will be our function px. This means first found multiplicator. What is multiplicator here? Is rho x will be exponenta x over x squared plus 1 dx. It will be e to the 3 halves ln x squared plus 1. If you remember, but you need to remember, exponential and logarithmic identity, it will be e to the ln. Now I'm doing each step, but future I think it can skip next couple of steps, and here it will be x squared plus 1 to the 3 halves power. We need multiplied our equation for this multiplicator. Okay, this equation will work. What we have now? We have x squared plus 1 3 halves power dy dx plus x squared plus 1 3 halves power times 3x over x squared plus 1 y equal 6x over x squared plus 1 times x squared plus 1 3 halves power. Okay, simplify. We have x squared plus 1 1/2 times 3x y. And this one will be equal 6x times x squared plus 1 1/2 power. My left part, my equation, I can rewrite how whole differential from x squared plus 1 3 halves power and y. And this will be 6x x squared plus 1 1/2. Okay, this means now we take it antiderivative, and this is give us x squared plus 1 3 halves power y equal integral 6x x squared plus 1 dx. Standard substitution here, x squared plus 1 it will be t 2x dx give me dt. It will be 3 times square root of t, and dt it will be 3 t to the 3 halves over 3 halves plus c, and finally we have twice x squared plus 1 3 halves power plus c. Okay, This means what we have here. X squared plus 1 3/2 power y equal twice x squared plus 1 3/2 power plus c. Found y, we have y equal 2 plus c times x squared plus 1 negative 3/2 power. This is our general solution. Solving two more example and from your book. I hope it's help you make it your homework. Question number 6. It will be x y prime plus 5y equal 7x squared, and here we have initial problem. This means y from 2 equal 5. Okay, first write is our equation standard form. This means dy dx plus 5 over x y equal 7x. How you remember coefficient y, it will be your px function. This is px. Okay. Found multiplicator or x, it will be e to the integral 5 over x dx e to the 5 natural logarithm x, it will be x to the 5th power. Okay, great. One more time, remember, multiplied your equation is standard form. Don't work with first equation. This means we have x to the 5th y prime, or dy dx, it's no big deal, plus 5x to the 4th y equals 7x to the 6th. Great. This means here you have x to the 5th y derivative. It will be 7x to the 6th. This means x to the 5th y integral 7x to the 6th dx give us x to the 7 plus c. This means y equal x squared plus c over x to the 5th. Plugging 2, we have y from 2 need be equal 4 plus c over 32 need be equal 5. I think we can see easy, c is 32. This means our particular solution, it will be y equal x squared plus 32 over x to the 5th. Okay. I think we're solving one more example. Well, let's go. It will be example 16. Y prime equal 1 minus y cosine x. Here we solution have initial point y from pi equal 2. Okay. Here we, one more time, we need to write a standard form. This means y prime plus cosine x times y equal cosine x. Okay, let's go. This means our multiplicator will be e to the integral from cosine x dx. It will be e to the sine x. Okay? E to the sine x y prime plus e to the, I write y is front, sine x times cosine x equal e to the sine x times cosine x. Okay, our left part is will be e to the sine x times y, take it integral, e to the sine x cosine x dx. What this give us? If you substitute sine x like c, this you can easily see it will be e to the sine x plus c. This means our y equal 1 plus e to the negative, just a moment, c times e to the negative sine x. And because we have y from pi equal 2, plugging we have 1 plus c e to the negative 0 equal 2. This means 1 plus c equal 2, c equal 1. And our particular solution, 1 plus e to the negative sine x. This is our solution. That's it.